So I've got our smaller pendulum set up here. You can see the pivot at the top is the string kind of clamped in here. And so it's going to pivot from that point at the bottom of this clamp. And down here, this is our mast that will be swinging back and forth, sort of just off the ground. I'll explain the card in a minute. But for now, just using a 2-meter stick, if I hold this about at the center of the mast at the bottom, looks like up here, our length is something like 157 centimeters. Kind of in that ballpark. I'm not going to measure too carefully with this, but what I will do is turn on our laser distance meter, and I'm going to hold this right up against the clamp and point it down so that it's reading off the white card right there that I've adjusted to be about in the middle of the center of mass of the weight. And these are the values that I get there. So those are pretty consistent. I'm pretty close. There are only a couple millimeters between those values. So we'll copy those down. We can figure out an average and maybe use that. So now for timing the period, what I've got set up is a ruler on the floor that I can use as a kind of visual reference for when it crosses the middle or the equilibrium position. And the important thing here is to time one whole period. So if I move it a little to the side and let it go, if I start the timer when it's crossing the ruler going to the right, and then stop it the next time it's crossing the ruler going to the right, then that time will be one whole cycle. So I'll illustrate here: start, stop. So that's giving me about 2.5 seconds. I can also, if I want to count multiple swings, I can start, lap, lap, stop. And so that was 3 cycles, and it's about 7.5 seconds. So that kind of checks out so far. And I can use the lap function on the timer here to keep track of the number of cycles it's been. So I'm going to go ahead and time out a whole bunch of cycles so we can get a good measurement of the period. So now I've got a total time recorded of 4 minutes and 13.91 seconds. And I was just scrolling back through the list of the laps just to double check. And you can see almost all of them here are between 2.4 and 2.6 seconds. If I scroll back some more, you can see 2.56, 2.6, 2.41, 2.55. So that's pretty good. They're all pretty close. I wasn't trying to time the individual ones very carefully. I was just kind of trying to make sure to tap it every time it went through a cycle. But one thing I noticed at the beginning is my very second lap. You can see there, it's the longest one, and it was 5.1 seconds. So what that means is I failed to press the lap button after the second cycle. And since I have a total of 100 laps, that means what I actually recorded is the time for 101 cycles. So since that took a little while to record, I'm not going to bother doing it again. We'll just do the calculation for 101 cycles. So if our time was 4 minutes and 13.91 seconds, what we want to do is convert these minutes into seconds so that we have the whole thing in seconds. So that's going to be 4 times 60 seconds plus 13.91 seconds. So 240 seconds plus 13.91 seconds. So that adds up to 253.91 seconds. So that's the time for 101 cycles. So I have to be a little careful here because I did 101 instead of 100. So our period then is going to be T101, the time for 101 cycles is just divided by 101. So if it was 100, I could just move the decimal place over. But since it's 101, I'm going to have to divide by 101. And I'm getting 2.5139 for that. Okay, so with the period measurement done, we'll just do another check of the length to see if anything changed. And let's see. Does look pretty much the same as we had before. We will get a slightly different value, but we'll go ahead and plug that in. Okay, so we've got our big pendulum set up outside now. I again have this card adjusted to be about level with the center mass of the ball. And I'm going to use that and the laser to measure the length of the pendulum. You can see got it clamped up there on the second floor landing, so I'm going to head up there with the laser now and we'll get a reading for the length. Okay, those look pretty good. We'll go ahead and set up and do some timing now. So you can see this pendulum is quite a bit slower due to the added length. I've got that card flipped on its side in the background to use as a marker reference. So if I start timing when we pass it, like now, and then stop now, looks like the period is a little over 4 seconds. So I'll go ahead and set up some long timing and we'll get a more accurate measurement next. So I went ahead and stopped after 50 periods because it felt like long enough. Got a total of 3 minutes, 27.39 seconds, and I just looked back through the laps and they're all just over 4 seconds. So I think we're good there. We'll just go ahead and use 50 instead of 100. And I'll go upstairs, get another length measurement. So let's adjust the card. Looks pretty close to the middle there. We can only do this part so accurately, but looks pretty good. I'll go ahead and get another measurement and then we'll see what we get. Okay, so there's our length after measuring the period. So we saw outside the time for 50 cycles was 3 minutes, 27.39 seconds. So let's figure out what our period is. First we'll convert the 3 minutes into seconds again. 3 times 60 plus 27.39 seconds. So that's going to give us 180 seconds plus 27.39 seconds. So 207.39 seconds for 50 cycles. Now our period is going to be T50, the time for 50, divided by 50. So that's going to be 4.1478 seconds.